All right, hello everyone. Welcome back. Today we're going to talk about covalent bonding. This is Unit 4, Lesson 2. After this lesson, you will be able to predict which elements are going to form covalent bonds, create covalently bonded compounds by drawing their dot diagrams, and define vocabulary terms related to covalent bonding. Before you start this lesson, you need to be able to quantify valence electrons based on periodic table trends, create Lewis dot structures, interpret Bohr models, and define the vocab words that are listed here. Let's think back for a minute to our previous lesson. We talked about how some elements will take electrons from other elements. So in this example, we have chlorine taking sodium's valence electron, and by doing that, they form an ionic bond. And in every ionic bond, you need a metal and a nonmetal. The metals in this case are acting as the electron source. So chlorine needs an extra electron, and a metal is what's required to give chlorine that extra electron. But what happens if nonmetals want to bond to one another? Let's think about some examples. So we've got oxygen, carbon dioxide. You breathe both of these things. I hope that there's no metal in them. Water. Again, ideally there's no metal in that. So if there's no metal in these compounds, where are the extra electrons coming from? Well, as it turns out, when nonmetals bond together, they share their electrons. So, to look into this, we are going to take a look at this simulator. Hopefully you will have a link to this simulator if I can convince CPS to allow that. Otherwise, you will just download it onto your computer. So, up here at this top toolbar, we've got a bunch of different elements listed. This toolbar on the left, we are going to maybe play with it a little bit later, but you can ignore it for now. So let's take a look back and let's look at oxygen first. Let's try to build oxygen in this simulator. So here is O, here is oxygen. I'm going to click it twice to put 2 atoms, because I know at least I'm going to need 2 because something has to bond. And let's take a look at what each of these atoms has around it. So I see 1, 2, 3, 4, 5, 6 electrons. And you can see the 6 is also reflected right here. And this oxygen is exactly the same. Now, the same rules, the octet and the duet rule from our previous lesson, are going to apply to all of these elements listed up here. So the goal for each of these oxygens is to turn their 6 electrons into 8. Now we just talked about they can share their electrons. So let's see what happens. I'm going to take 1 electron from this oxygen and 1 electron from this oxygen. And together they form a bond. And you can see now we've got 7 in the middle of both of these oxygen atoms. But let's take a second and double check our math. So on this oxygen atom, I see 1, 2, 3, 4, 5 electrons. So where am I getting 7 from? Well, you get to count both electrons that make up the bond. So each of these oxygen atoms has 5 electrons around it, plus 2 electrons in the bond, and that gets us to 7. But we're still not quite satisfied yet, because ideally we want 8 electrons, not 7. So let's make another bond. And look at that. Now we have 2 very happy oxygen molecules. So let's do our math again. We've got 1, 2, 3, 4, 5, 6, 7, 8 for this oxygen. And for this oxygen, we have 1, 2, 3, 4, 5, 6, 7, 8. All right, I'm going to scoot this guy out of the way, and we are going to build our next molecule, which is going to be carbon dioxide. So for carbon dioxide, I'm going to need one C and two O's. And let's go back and check that formula. So you can see here we've got one carbon and two oxygens. Now you might be wondering why I decided to put them in this order. So I've got an oxygen, then a carbon, and then another oxygen. Well, when I try to form covalent compounds, I like to put the atoms that are by themselves in the center. So in this case, I've got two oxygens and one carbon, so I'm going to put the carbon in the middle. And don't get overwhelmed. The first step, even when you have 3 or 4 different atoms, is to just start forming bonds. So carbon is in the middle. I'm going to make one bond between each oxygen just to start. That way everything is connected together. All right, so now this carbon in the middle is not quite happy. It has 6 electrons. We can do a double check. 1, 2, 3, 4, 5, 6. And each of the oxygens have 7. So 1, 2, 3, 4, 5, 6, 7. So that means that we need to keep forming bonds. So I'm going to take this electron and match it up, and look at that. This oxygen is happy as a clam. We have 1, 2, 3, 4, 5, 6, 7, 8. And if we look over here, we've got 7 electrons for this oxygen and 7 electrons for this carbon. So I bet you can predict what I'm going to do. One more bond. And now if we do our math, this oxygen is going to be just the same as this one, and this carbon has 1, 2, 3, 4, 5, 6, 7, 8. All right, that is carbon dioxide. I'm going to scoot this out of the way. Maybe I need to make that easier to move. And let's look at our last molecule, which is going to be water. So in water, we've got H2, which means we need 2 hydrogens and 1 O, so 1 oxygen. Now again, I decided to put the oxygen in the middle here, just like I put the carbon in the middle here, because I have 2 hydrogens and 1 oxygen. So the one with only 1 atom goes in the middle. And then I'm going to start making bonds. So I'm going to take this electron on hydrogen, connect it to oxygen, and look at that, hydrogen is already happy. And that is because hydrogen follows the duet rule, where it only needs 2 electrons to be happy. And now we're going to do the same thing on this side. And look at that, we've got hydrogen with 2, and the math for this guy is just this one bond. So you just count 1, 2, and that's it. And oxygen, we've got 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so those are our 3 covalent compounds. Now we are going to go back to our slideshow, and we are going to talk about some vocabulary words. So this is oxygen that we just built. And each of these 3 boxes has a statement that probably seems a little bit obvious to you. So this molecule is made up of 2 atoms, right? 1, 2. This molecule is made up of the same atoms. They're both oxygen. And there are 2 bonds between the atoms in this molecule. 1, 2. So in chemistry, we have vocab words that are going to tell us these things without us having to write down this whole sentence every time. So let's look at the first one. This molecule is made up of 2 atoms. We also call that diatomic. So if you look, the root word here, di, in a lot of, I think, like Latin languages, di means 2. and then atomic. So 2 atoms, diatomic. All right, this molecule is made up of the same atoms. We call this homonuclear. If you remember from our unit on matter, when we did homogeneous mixtures, homo means the same. And then nuclear, in this case, we are talking about the nucleus of the atom, which is where we would figure out what element the atom is. So, same element, homonuclear. And finally, there are 2 bonds between the atoms in this molecule. We would call that a double bond. All right, let's look at carbon dioxide. This molecule is made up of 3 atoms, and we actually don't have a word for this. We don't say triatomic very often. Just know that this is not a diatomic molecule. So if you see carbon dioxide and it says, is this diatomic? You would say no. All right, moving on to the next one. This molecule is made up of different atoms. So we have an oxygen, a carbon, and an oxygen. So that carbon being different means this is not homonuclear, this is heteronuclear. So hetero means different, and again, nuclear just tells us the nucleus of the atom or the element. And finally, there are 2 bonds between the atoms in this molecule. So this is the same as before. It's a double bond. Now, this can get kind of confusing because we have 1, 2, 3, 4 bonds total in this molecule, but we're not going to call this like a quadruple bond. We would say that there are 2 double bonds. You're really only ever going to classify the bond between one atom and another one. Oop. All right. And our last one is water. So this molecule is made up of 3 atoms. So is it diatomic? Nope. This molecule is made up of different atoms. So it is, I didn't change that. That should be heteronuclear. Should we change that right now? Really don't feel like having to redo this video. Okay, heteronuclear. And there is only 1 bond between the atoms in this molecule. So we would call that a single bond. All right, and that is it. Here are your vocabulary words. They should be pretty straightforward because we just went through a lot of examples of the last 5. So go ahead, copy these down. There is a Quizlet that should be in your Google Classroom if you would like to practice, and you can move on to your bronze assignment.